الماضي وقت خلصنا الكونفرنس من هون ورحت على البيت، يبعث لي عمر جبلي صديقي هو قاعد هون. هاي عمر يبعث لي شيء على الانستغرام انه the first exoplanet with biosignature was detected. It was just 3 hours بعد التوك اللي عملناه هون. فتت انا على النيوز. It was all over the news. CNN, BBC, New York Times, وزارة المينستري اوف انفورميشن بلبنان هالقد مهمة حطوها. رحت انتم من بعد التوك اللي سمعتوه مرة الماضي صار فيكم بالانفورماسيون اللي اي هوب تعلمتوها ما بتسمعوا سي ان ان وبي بي سي وريبابليك اوف مينستري اوف انفورميشن، بتروحوا دايركتلي على البيبر. and with the background اللي تعلمتوه مرة الماضي صار فيكم تفهموا the scientific paper. رح نجي على scientific paper. It was published on 17th April 2025. نحن التوك تبعنا كان 16th April. So the second day it was accepted 15 يعني probably حطوه على الارchive on the 16th, the day of our talk last week. The sub-Neptune frontier. مين بيتذكر شو sub-Neptune؟ بتذكروا هذا الجراف؟ The mass of the planets and the radius. وقلنا في planets اقل شوي تقلن والماس تبعهم من نبتون واكثر من ايرث. So this is the sub-Neptune frontier with planet-wide oceans and H2 rich atmosphere. حكينا عن بلانات فيهم اتموسفير فيها هيدروجين موليكولير H2. Recent James Webb transmission spectroscopy. شو transmission spectroscopy؟ بتتذكر وقت البلانات تقطع قدام الستار and part of the light of the planet of the star goes through the atmosphere of the planet and it can be detected as a spectrum. So transition spectroscopy. In the near infrared هيدا في paper قبل هيدا اسمها البلانات K218b. The first detections of carbon bearing molecule CH4 and CA2 in its atmosphere. أنا قلت لكم المرة الماضية إنه الميثان is a signature gas of life. It cannot be processed in geological processes. ما في يجي من البركين من الأرض، بده حياة لتعملوا الميثان. دونك ديجا هيدي ميثان. هلا هيدا البيبر جديد بريبورت mid infrared transmission spectrum. هيدا كان بالنير انفراريد. إذا بتتذكروا حكينا عن سبكتروم الانفراريد، هيدا ما بنشوفه بعيننا بالانفراروج. النير انفراريد هيدا بالميد انفراريد. Transmission spectrum obtained etc. ديميثيل ديسلفيت وديميثيل سلفيت هن الموليكيول يلي بيجوا من وراء الحياة. These molecules cannot be generated by geological processes. Hence the announcement of the first هلا بالميديا بيضخموها. ليك شو متواضع التايتل تبع البيبر. New constraints on DMS and DMDS dimethyl sulfate dimethyl disulfate in the atmosphere of this planet from the James Webb Telescope MIRI الانسترومنت اللي بيقيس بالانفراروج. اوكي to 3 sigma significance اللي بيتذكر كل ستاتستيك sigma يعني ايكار ديب 3 standard deviations. Standard deviation is around 67%. 3 standard deviations يعني 99.7% يعني في chance انه 0.3% انه this discovery may be just chance. Usually in physics لحتى ياخذوا نوبل بدها تكون 5 sigma significant يعني 99.99 something percent. Okay, so it's still so هلا بس تقروا كمان من مره تعلمتوه مرة الماضي بتقروا semi major axis. بتعرفوا semi major axis اللي تبع الاليبس eccentricity 0.09 منا على circular orbit. orbital period 33 days يعني بدها 33 يوم لتبرم على البلانيت تبعها. المين راديوس 2.6 ايرث راديال يعني مرتين ونص الراديوس تبع ادريس تبع الارض. والماس تبعها 8 مرات الماس تبع الارض. سو 8 مرات يعني هون هذا لوغاريتميك 1 2 3 4 6 7 يعني هون و2.6 راديوس يعني بتوقع هون. It's a sub-Neptunian planet with a signature of gas. هيدا السبكترم تبعها. هلا صرتوا بتعرفوا شو سبكترم، بتعرفوا شو ترانزيت. هذا الترانزيت اللي فرجتكم اياه المره الماضيه. سبكترم هذا الثيوريتيكال مش ثيوريتيكال هذا باللاب ميثود من السي اتش 4 سي او 2 ديميثيل سلفيت يا حنه and if you put them all together بيعطوكم السيح الاسود and this is the spectrum observed of this planet. رح تشوفوا نفس الابسوربشن لاين يلي measured in the lab. ليكو الديب is 0.003 تقريبا. مين في يقول لي قديش الراديوس تبع هاي البلانيت من ورا الديفرنس ان ذا فلكس؟ قلنا الديفرنس ان ذا فلكس will be the ratio of the square of the radii. So بتاخدوا 0.003 تعملوها راسين كاري بيطلع لكم قد ايه الراديوس تبعها للبلانيت. اوكي؟ سو رح نقطع هلا. It was worth stopping here because it was انا مرة الماضية قلت لكم maybe it will require us hundreds of years, maybe thousands, maybe millions of years. مرة الماضية قلت لكم في zero planet detected, and this was announced only 3 hours after our talk last time. What a coincidence. كنت قايل لكم انا يمكن ننطر مليون سنة لنلاقي بلانت مثل هذا. So بقول لكم قد ايه the universe is strange and strange things happen all the time. So if you take a moment to look around you, really look, you will see complexity everywhere. إذا بتطلعوا بالعالم رح تلاقوا عالم، بتطلعوا ديب، تنسوا الانستغرام شوي، بتشوفوا إنه ديب اللي بتطلعوا بالعالم رح تشوفوه complex. في شجر، these are wonderful structures that give us oxygen to breathe. في volcanoes, في oceans with creatures, في human beings, complex human beings, في minerals, في cities that have been built through time and dedication. You will see patterns, layers, and forms. You will see complexity in every way you look in your daily life. ما عم بحكي تطلعوا على الكون ونجوم، طلعوا بالحياة حواليكم. And all of our human history in some sense is a celebration to this complexity. Every book we have written, every piece of art, every piece of music is a celebration to the complexity that we find in our life. بعدين واحد, and sometimes you will ask a question, was this world created complex? Or it was simple and it evolved to become complex? Why is the universe capable of this complexity in the first place? And why is there structure at all? Stars burn, planets form, molecules combine, minds think. This has always been a philosophical question. Also, it is a religious question to some extent, but at its core, it is a scientific question. ليه العالم كومبلكس اللي حوالينا؟ ليه في نظام؟ ليه في structure؟ ليه في forms؟ ليه موجود the way it is? What is the world made of? This question stretches to as long as people started to think. They thought in the beginning that the world was made of 4 elements: fire, air, water, and earth. So هدول the 4 elements, and it's amazing how people thought of this in different cultures. Yani in the Indian continent, in China, Japan, the Greek philosophers, in the Latin America, they thought of the same. And they thought that everything in our life is made of a combination of these elements together. They thought also that these elements can be transformed from one to another. They had something called alchemists. كان عندهم scientists و philosophers يسمون les alchimistes. Alchemist يعني حدا عم بفتش على الphilosopher's stone. هي ذاتها تبع هاري بوتر by the way. So it's a stone, mythical stone that can transform in particular lead to gold أو حديد للسيلفر. فكروا بالماتير، كانوا عم بفتشوا على طريقة لحتى يحولوا الماتير. وقضوا سنين doing this, and you may be surprised to know that Newton, after he turned 25, he gave us the law of gravity, the laws of motion, the nature of light, and we use his laws until today. He turned 25 and he stopped doing science. He spent the rest of his life doing alchemy. قضى كل حياته نيوتن جرب نلاقي philosopher stone. It's amazing to see that. So their instinct wasn't entirely wrong. Democritus, a Greek philosopher, 4th century BC, وقتها كانوا philosophers, they were not philosophers, they were scientists also. They thought about the natural world. And he had a thought experiment. If you take a piece of material, let's say wood, you cut it in half, and then you cut the other one in half, and you keep cutting in half, can you continue doing this to infinity? And he came with a guess, with a bold guess, that you cannot do this to infinity. You will reach a place where you will find a piece that you cannot cut, سميها atomos, in يعني ما بتتقسم بقى, indivisible. And this was, on a bold guess, the foundation of the most important discovery in science, which is atoms. We waited until the 20th century. Niels Bohr, Ernest Rutherford, the lab, they discovered with experiment that atoms existed. So what we know today, we know that matter is made of atoms, كلنا بنعرف. And atoms are not indivisible particles, they are made of subatomic particles. It's made of nucleus. Nucleus فيه protons, neutrons, and it's surrounded by electrons. The protons, they have a positive charge, neutron neutral, والelectron negative. هيدي بيدرسوها بصف توازيان يمكن بالمدرسة أو بالسنكيان هلا. We all know this. And it's interesting to know that the size of the nucleus is 100,000 times the size of the atom. So إذا بتاخدوا الأتوم, you scale it at the size of a cathedral. The size of a cathedral. The size of the nucleus will be the size of a pea. نحلة بقلب الكاتدرال. So 99.99999% of the atom is void. C'est un vide. So the number of protons determine the elements. يعني إذا بتحطوا بروتون واحد بيطلع لنا هيدروجين. 2 protons بيطلع لنا هيليوم. 6 protons بيطلع لنا كربون. Et ainsi de suite. So if you were God and you wanted to create the universe, you will create protons. بتحطهم هيك بقلب مثل البازل، بتصير تركب بروتونز على بعض، بتركب كل العالم حواليك. بتركب الهيدروجين والماء والحديد والمغنيسيوم والكالسيوم just by adding protons together. So the alchemists, they were not wrong. They were searching for something and it is right. The problem is that combining protons together is very strong لأنه في شيء اسمه Coulomb force. تعرفوا أنتوا things of the same charge they repel. كل العالم تعرف إنه بتأدي مغناطيس from the same side they repel. هيدي اسمها Coulomb force أو electrostatic force. But this force operates on large distances. You need to bring them together very, very close until another force of nature, اسمها the strong nuclear force, takes over. Okay? So إذا تاخد 2 protons بتقربهم على بعض they will repel. بتضلك تشدهم ما بيقربوا على بعض مغناطيس. بس إذا بتقدر تقربهم على distance أصغر من 10 to the power minus 15 meters, this is 1 millionth of a billionth of a meter. يعني 1 thousandth of a billion of a millimeter. إذا تاخدوا مليمتر بتقسموه ل 1000 مليار شقفة، هذه الديستانس اسمها femtometer. So this force is attractive on small scale. So هذه الكولوم فورس تصغر مع الديستانس، بس at small distances this force is very strong and it will attract these protons together. Okay? It's a concept of atomic physics, but it's important to know. So you can add protons. بتحطوا protons بيطلع لكم هيدروجين، 2 بيطلع لكم هيليوم، بتحطوا 6 شو عم بيصير؟ بتحطوا 6 بيطلع لكم كربون، بتحطوا 28 بيطلع لكم حديد. So كل ما زيد عدد البروتونز بيكبر السايز تبع النيوكليوس، بس المشكله انه the Coulomb repulsion starts being significant لانه عم ناخذ على ديستانس اكبر، وصار بصير الاتوم ببطل ستابل. مشان هيك في نيوترونز بالاتوم to make it stable لانه النيوترونز they don't feel the repulsion of the Coulomb barrier. لانه ليش؟ لانه ما عندهم شارج، they are neutral. So بيلزقوا البروتون مع بعض. So كل ما تزيد بروتونز تطلع بتزيد البايندينج انرجي لحديد ما توصل للحديد the magical number. بعد الحديد بتصير تخسر انرجي when you fuse. For things that I will not explain now, but this is the principle. So كل الانرجي النوكلييريه اللي بنولدها على الكره الارضيه هي by fission. They fission uranium to lighter elements. هيدي الانرجي by fusion بعد ما بنقدر نعملها نحن على الكره الارضيه. We cannot do this yet. So you take proton. تتذكروا هيدا تابلو دو ماندليير. كل رقم هون مين بيعرف شو بيعني هذا الرقم 1 2 3 4 5 6 7 8. This is the number of protons. So it's very simple. You can create the world with a combination of protons. So hydrogen عنده 1 هيليوم 2 ليثيوم 3 بريليوم 4 بورون 5 كربون 6 نيتروجين أكسجين فلور نيون etc. Okay? The universe gave us only hydrogen and helium. بأول كون كان في بس هيدروجين وهيليوم. ما لحق الكون يعمل بروسيس لماتيريال أكثر. How are all those atoms made? They are forged inside the stars. So the stars are the true alchemists of the universe. هن يلي they fuse the matter وبيعطونا the diversity of matter that we see in the world. So what happens inside the star is that two atoms of hydrogen they fuse together to become helium. ليش؟ لأنه in the heart of the star the density and pressure are too high and the temperature is high And if you remember, the temperature is just the measure of the kinetic energy of the atoms. So they move very fast, they bump into each other, they cross this barrier of 10 to the minus 15 meters, and they are taken by the strong nuclear force and they bind together. And this fusion releases energy. And this is how the energy of the sun is released. So قبل كانوا يفكروا they thought that the sun was powered by chemical energy، مثلا على الديزل تمشي أو على الفيول ما بعرف. بعدين فكروا إنه it was powered by gravitational energy، عم تصغر and it's releasing heat. بعدين اكتشفوا in the 1920s that the sun is powered by hydrogen fusion. So what happens if you take a ball of gas, you put it in the space, and you wait millions and millions of years, it has mass and it's subject to gravity, and it starts collapsing on itself under the effect of gravity. وتبيصغر this ball, it's the same matter in a smaller volume, so the pressure increases. So the pressure increase شو بتصير؟ temperature. بتذكروا equation PV equal nRT يلي بعده طالع فريش من المدرسة. So it reaches temperatures of 10 million degrees ويبلش الهيدروجين fuse to helium and it gives pressure. يعني بصير مثل منظر البريستو بيعلى الضغط بتاعلى الحرارة. It's the same, exactly the same. And the cloud stops collapsing because it's balanced by an outward pressure generated by the emission of heat from this nuclear fusion inside the star. And the star is a constant battle between the gravity that tries to pull it down and the thermal pressure that fights gravity and tries to pull it back. هذا شيء اسمه hydrostatic equilibrium, and you take the gradient of the pressure with radius should be equal to the gravitational force by unit volume throughout the layers of the star. So as long as the star is in this equilibrium, it's safe. هلا الشمس تبعنا is in this equilibrium and it is safe. When this equilibrium is broken, dangerous things will happen and you will see later. So our sun is burning hydrogen to helium, but the hydrogen at the core will be elapsed، رح يخلص. ما هيك؟ لأنه في a finite amount of hydrogen. So في hydrogen burning core وenvelope ورا ما فيها hydrogen burning, and helium is created. Hydrogen in the core is converted to helium. So the helium mass grows with time because the hydrogen is being transferred to helium. When this does, so this helium is not burning. So there is no more nuclear reactions at the core, and there is no more outward pressure to combat gravity, and gravity will take over, and in that case, the core will contract under the effect of gravity. When the core contracts under the effect of gravity, شو بصير؟ تعلى البريشر، تعلى التمبراتير, and this will be enough to generate a fusion beyond helium. So when the star reaches this stage, it will start burning hydrogen in a shell and it will expand لأنه الهيدروجين صار عم يحترق قريب على السيرفاس, and it will become what is called a red giant. بتصير une géante rouge. الشمس يلي النجمة يلي تقريبا عندها the same mass as our sun. Okay? So this is what will happen with our sun in few billion years when the hydrogen will be used. بيخلصوا بنزيناتها الشمس خلاص. ببطل في شيء reaction at the core. بصير helium core ما عم يحترق and surrounded by a hydrogen burning shell. بتصير تحترق ال burning shell and it expands the layers of the star out, and this will be the end of Earth and the solar system. Okay? So what happens is that the helium eventually it will compress رح يكبر على الجرافيتي بيطبق it reaches temperature of 200 million degrees, and this is enough to start fusing helium. وتحترق الهيليوم شو بصير؟ 3 atoms of helium دول بيعطونا كربون واكسجين. بيحترق الكربون، كل الكربون اللي موجود بالطبيعه بجسمنا نحن والاكسجين معمول بنجوم، الكربون اللي بالكونستركسيون هون معمول بنجوم. Every atom of carbon came from a star in the universe. So what happens هلا بصير انه the outer layers are loosely bound. بتصير تعمل pulsation the star and it ejects all its material in space. And this is called a planetary nebula. هدول beautiful pictures you see, these are planetary nebula. At the core there is what remains from the star. It is the ball of carbon and oxygen that cannot burn further because there is not enough gravity, and the gas is ionized and it emits in these beautiful lights. And what remains is a ball of gas densité تبعها مليون تايمز denser than water. يعني بتاخدوا متر مكعب الماء بيوزن طن، هون بيوزن مليون طن متر مكعب منها هيدي. It's so dense. And this is called a white dwarf, une naine blanche. في كتير نجوم نحن our sun will become a white dwarf after billions of years when the hydrogen will be all used. And it will grow, it will reach the orbit of Earth, and then this will be the end of the solar system and the sun will become a white dwarf. So this is the end of a sun, of a star that has the same mass of our sun or few solar masses. These are real telescope pictures. So this is not an animation, these are real pictures stacked together. Zooming on a planetary nebula, 780 light years away. نحن هذا رح تشوفوها بتبين. So this is what the cells of the star that has been ejected into space, and at the core there is the white dwarf emitting radiation that ionizes the gas. Now the evolution of a high mass star is a star أتقل من النجم تبعنا. It will have enough gravity to start burning beyond carbon. The carbon will start burning to neon, and then the neon will start burning to magnesium. So كل مرة بيخلص برودوي بيخلص thermal generation is stopped, gravity will take over, it will contract, it will generate pressure and heat, and it will start burning, and the new cycle of the star will, so this will have, so it will have the star, it will have this structure, it will have a hydrogen burning shell surrounding a helium burning shell, surrounding a carbon burning shell, neon, oxygen, silicon, until iron. By the way, بتاخد النجمة اللي 25 solar masses 7 million years to burn hydrogen to helium. Our sun takes 10 billion years. These are ferocious objects. They burn their fuel very fast, and it burns the oxygen in 6 months only. And the silicon, when it burns silicon, the star has only 1 day to live. Once بيصير في iron بقلبها, the star cannot live anymore. بتتذكروا قلت لكم the iron, you cannot burn beyond iron لأن burning beyond iron consumes energy on the thermic, ما بتعطي energy. So once the star burns iron in its core, there are a series of events that will lead to a catastrophe. So what will happen that burning beyond iron does not release, it consumes energy. So the burning stops, the iron core reaches a limit, and it starts collapsing under the effect of gravity. خلاص ما بقى في شيء وقت الكولابس. So the gamma rays are very, very strong. It will bombard the iron's nucleus and it will dismantle them into protons and neutrons. And the protons and the electrons at density قوية, they will bind together to form neutrons and neutrinos. So the core becomes a mass of neutrons. تتذكروا الكاتيدرال والبي in the cathedral. تخيلوا مثلا 30 كاتدرال حد بعض قد ايه بياخذوا فوليوم. تخيلوا خلصنا من الفوليوم وخلينا بس البيز النحل اللي بقلب اللي هن نويو ستاك ببعض قد ايه بياخذوا فوليوم. تخيلوا الدنسيتي تبع الماتير. So what happens is that the core will collapse. بيقع الكور لبعضه. The outer layers of the star do not have the time to react to this, so they will see themselves held in space and they will fall immediately. This is exactly like the coyote falls, and the shell will fall at a fraction of the speed of light. It will hit the dense core, generate a shock wave, and the shock wave will go out and it will expel everything in space. And this event is called a supernova. And when the shock wave passes, it processes all the material that you saw in the periodic table. من الهيدروجين لليورانيوم. كل elements they are processed in this small few second explosion of the supernova, and it's expelled into space. So the core, it collapses in fraction of a second. It releases energy of 10 to the power 44 joules. نحن الشمس it releases 10 to the power 34 joules. يعني 10 orders of magnitude more than the sun. يعني مش بواديس 10 zeros. يعني the sun will release energy in 10 billion years as the supernova will release in few hours. إذا بتاخدوا كل الطاقة اللي عم بتطلعها الشمس بتضربوها ببنك بعد 10 مليارات سنة يا ريتهم البنك. Yeah, I was done. You compare them to the supernova, بيطلع the same energy as the supernova. It's mind blowing how energetic these explosions, and these are one of the most violent explosions in the universe, and they built all this matter here. So كل شيء فيكم المغنيسيوم، مين منكم بياخد supplement مغنيسيوم بدمه؟ اللي بياخد مغنيسيوم، the magnesium is made in these processes. So every atom of magnesium you take is made in one of the stars that exploded at the supernova billions of years back. So this supernova in هذه الصورة بتعرفوها the Crab Nebula مشهورة. So it's the remnant of a supernova that exploded 1,000 years back, and the Chinese had record of this supernova. It remained for 2 months visible during daylight. One of the stars that will go supernova soon on astronomical scale is Betelgeuse. This is the star that you see in the Orion Nebula, and when it will go, it will be visible even during the daylight, and it will be the most spectacular event that history has ever witnessed. رح تضل visible during the daylight مثل الشمس هالقد قوية for 20 days. So the story may continue for white dwarf. تتذكروا الوايت dwarf, the star that has the carbon and oxygen. It may be a companion to a red giant. لأنه stars in the universe, they don't form as one. Sometimes they form as two. And one of them is heavy. It will evolve to become a red giant faster. And this white dwarf will channel material from the red giant. We saw this animation before. And this is another type of supernovae. So the material will be channeled by gravity to the center of the white dwarf. And the white dwarf will gain mass. And the mass, it will increase the density will increase the temperature will reach billions of degrees, and then the event will go kaboom as a supernova type 1A. And these are some of the most violent explosions in the universe. ليكوا هيدي وحدة عم تنفجر، ليك الضوء تبعها compares to the light of hundreds of billions of stars in the galaxy. So this is, by the way, هيك off parenthesis, this is my own research. I do the research about these supernovae type 1A, and I try to identify the elements in their ejecta as the ejecta evolves. هيدا عم تشوفها silicon, carbon, oxygen, magnesium, so calcium, iron. Okay, so these are things that I do myself. So you wonder how people do the research. منا صور هيك حلوة وانيميشن. So it's something different. So this is the life cycle of stars. You start with the gas, with the gas nebula, gas giant. And part of the gas will collapse under the effect of gravity. It will make a sun-like star. It will spend billions of years burning hydrogen to helium. It will become a red giant, then planetary nebula, and the remnant will become a white dwarf. And whatever material ejected will go back. It will be recycled in the interstellar medium, in the gas. If a star is massive, it will be a massive star. It will come red supergiant in millions of years. Not billions of years. It will become a supernova, and it will eject all the material back. It will recycle back in the interstellar medium, and the remnant will become a neutron star or a black hole. هلا نحكي عنهم بعد شوي. So the gas in the interstellar medium اللي كان بس hydrogen helium, it's enriched with time by stars dying and putting back in the gas all the elements that are built. And you wait millions of years, and a new sun-like star will form. Now, with a planetary system around it that has calcium, it has silicon, it has sulfur, magnesium, and you can build planet and you can build life the way we see it on our planet Earth. So our sun is a second or a third generation star. It's the debris, recycled debris from a previous star that died in the universe. It's not a generation one star. So our cities are built with this material. إذا شي مرة سألته الحديد فيه كربون وايرون ومنغنيز اللي بيستعملوا بالكونستركسيون. السيمنت هو كالسيوم وسيليكون والومنيوم وايرون. الكالسيوم وكربون اوكسجين للحجار for the stone, and the glass is silicon and oxygen. Every atom of material in this building was made by a star long time ago. And if you don't see this idea poetic, then what أعمل? So these are the elements that are built in شفناها. So what is left? شو بضل من السوبرنوفا؟ قلنا بضل remnant بصير يا neutron star يا black hole. So these are the neutron stars. So these are the remnant of the core. إذا كان تحت 3 solar masses. it will become a neutron star. تتذكروا الاكزامبل تبع الكاتدرال will be, so the matter is mostly void, so you can compress it further and further and further until you reach objects that are 10 to the power 17 kilograms per cubic meter. الماء is 10 to the power 3 1000 كيلوغرام بالمتر المكعب، يعني عم تحكي 14 صفر دانس اكثر من الماء. In a small object, and these objects they keep rotating very 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 fast لانه بيكونوا عم يبرموا على البطيء and they shrink in size, and because of conservation of angular momentum مثل دانسوز الباليه اللي عم ترقص بتضب ايديها بتصير تبرم على بتصير اسرع. So this what happened, they rotate maybe 700 times per second اسرع من الموتور من الكمبرسور. If the remaining core is more than 3 solar masses, it will become a black hole. So in that case, all the matter will keep collapsing and nothing can stop the collapse. So what بتسمع كلمة black hole, black hole is the remnant of a big star, of a massive star that has died and it has collapsed. So شو بيصير بالبلاك هول؟ لأسرعكم شوي صغيرة عن البلاك هول. تتذكروا الانالوجي اللي اعطيتها مع الابل، when you throw an apple بتطلع وبترجع بتعطيها kinetic energy potential energy بتقل بتوصل kinetic energy zero بترجع بتنزل. But there is a velocity that you can use to throw the apple and it can escape planet Earth. And then you will ask your question, what if an object is more massive than Earth? So you can play with m here and you can ask what the velocity can reach. And there's a velocity, if you equate it to the speed of light, you will reach a radius within a mass that you need to the velocity to be higher than the speed of light to escape the object. يعني بتصير في مش 11,000 كيلومتر بر سكوند، بتصير توصل 100 كيلومتر بر سكوند. You calculate the radius وهذا اسمه the Schwarzschild radius. So the black hole is an object from which the escape velocity is higher than the speed of light. So ما في شيء كثير. بتتذكروا هيدا السال ب Interstellar وقتها هذا الاكتر ما بعرف شو اسمه ميكانيك، وقتها بيروح على الايفنت هورايزن. when you listen the word event horizon means the Schwarzschild radius. It's the radius from which you need to be faster than the speed of light to be able to escape. Okay, so strange things happen inside and you can amuse yourself by calculating what is the Schwarzschild radius of planet Earth. يعني اذا اخذت هالماس تبع الكره الارضيه and you compress it قد ايه بده يكون ريون لتصير بلاك هول؟ تطلع الكالكول بدها تكون اقل من سنتيمتر. اذا بتاخذوا الماس تبع الكره الارضيه وميك ات less than 1 centimeter it will collapse into a black hole. You can amuse yourself by doing the calculation too. اذا انا باخذ 80 كيلو بعمل بحط الماس هون بيطلع لي الريون قد ايه بده يصير ليصير بلاك هول. Okay, so these things apply to anything. It doesn't have to be big. So we return to our opening question. How could a world so complex have come to be? Why does the universe exist as it does? Why is there such perfect harmony, such fine-tuning that life can emerge? Why there is order instead of chaos, structure instead of noise? Why there is something rather than nothing? We now know the ingredients. نعرف كيف الهيدروجين بتحول بصير هيليوم وكربون، بالنجوم بيموتوا بيصيروا سوبر نوفا، بيرجعوا نجوم ثاني بيعيشوا بيخلقوا كوكب وحياة. But this is not enough. We need the right recipe, and the laws of physics must be just right. Why does the universe have constants that have exactly these values? هيدي الشغلة اسمها the fine tuning problem. يعني إذا كانت الجرافيتي شوي أقل، الفاليو تبع الجي gravitational constant أقل بشوي، galaxies would not form and stars would not form and planets would not form. إذا كانت the speed of light شوي أقل مما هي كان the Schwarzschild radius كان أكبر، كانوا all the stars instead of becoming supernova and ejecting the material in space they would have collected in a black hole and we didn't have any oxygen, any magnesium, any calcium, any iron to make planets. All the constants, if the strong nuclear force was not enough to put 6 protons together to form the atomic, the carbon, we wouldn't have life. ما كان عندنا carbon. So people ask, why is the universe fine-tuned لدرجة هالقد دقيقة to allow for life and the universe to exist? كأنه the universe is balanced, كأنه it's a really really fine balance، كأنه هالقد مثل هذه الصورة هالقد صعب يكون the universe tuned the way it is. من هون اجت فكرة the multiverse. People فكروا انه مش معقول يكون by chance that the universe is this. هلا صرنا بطل السيانس صارت فيلوزوفي لانه this cannot be tested. but it's no harm in talking about this. So the multiverse is the idea that infinite universes exist, each with different laws, with different constants of nature, and we just happen to be in the universe that allow for life to exist. And we ask these questions. Okay, so this multiverse idea was discussed also from 600 before Christ. مثل ما before Christ he predicted شو اسمه Democritus the atoms, and بعدين بين بعد 2500 سنة انه the atoms exist. مثل ما Giordano Bruno predicted the existence of exoplanets, and after 500 years we discovered them. These people predicted the multiverse, and we may never know that if this exists or not. So is it by chance? Is it parallel universes with different laws and constants? Perhaps life didn't arise in some of these worlds or exists in forms we cannot imagine. We happen to exist in this particular one that allows life. Are we here by necessity? Is there something deeper we don't yet understand? So when you look again in the night sky or the world around you, you might realize how much the universe and the life within it could be a rare miracle. And that you are not just observing the cosmos, you are the cosmos asking itself why it is here. كل واحد منا is part of the universe، معمول من نفس الاتوم اللي معمول فيه كل الكون، بس احنا مجموعة اتومات معمولة بطريقة كومبلكس، بنقدر نسأل why the universe is here، بنقدر نفهمه. And we can write the language of the universe in a language we can understand. And this is not astonishing, this is mysterious. And maybe the most challenging question of science is not to understand the universe, rather to understand why it exists and can be explained. As Einstein once said, the most incomprehensible thing about the universe is that it is comprehensible. The fact that it is so comprehensible is an eternal mystery. Thank you.